So now we're actually going to talk about partial fraction decomposition. And one of the questions I sometimes get asked at this point is, Mr. Rivers, why did we just do solving systems of equations and now all of a sudden we're adding rational expressions? So in this video, you'll see why we did solving systems of equations first. We will get to a point where we need to do that. Now first, I want to sort of motivate what we're doing in this video. And so I'm going to write something down. In the previous video, we just added rational expressions. So let's say we were adding, just as an example, 2 over x plus 1 plus 5 over x minus 3. If you add these together, I did this beforehand, you would end up with 7x minus 1 over the common denominator would be x plus 1 and x minus 3. So you could show this, you could do this out. Now, we've gone, in all of the other examples, we've gone left to right. So we started with some sort of expressions to add. However, in calculus, it's often useful to be able to go back the other way. And so what I mean by that is we'll be starting with expressions that look like this. Whoops. And we're going to end up trying to get to, our goal will be to get to basically what we started. So it's sort of undoing what we did in the last video. All right, so once again, our goal is going to be, we'll start with one rational expression and we're going to want to break it up into different parts. And so this process here, going from that, this part is called partial fraction decomposition. Now most pre-calculus teachers will call this PFD. It is not a widely used or widely recognized acronym, but it is something that many pre-calc teachers still use. All right. So let's see how this might work for an example. Let's go ahead and find, I'll write it all out this time, but after this I'll probably just use PFT. So we're going to find the partial fraction decomposition of 3x minus 37 over x plus 1 and then x minus 4. So the first step is just to kind of think about what our final answer will look like. And what you're going to do is you're going to take each linear factor, and each one of these gets its own fraction. So we start off by saying, I know that the answer is going to have this format. It's going to be something over x plus 1 plus something over x minus 4. Now I don't know what those somethings are, but I do know that they're going to be numbers. So up here you'll see that we have just single numbers, 2 and 5. So I do know that they're going to be numbers. So let's just pick letters to be those numbers. Now usually, for whatever reason, capital letters are used here. Capital A and capital B. If we had more, we'd just keep going C, D, etc. I'm not sure historically why the capital letters get used. If you would rather use a lowercase a and a lowercase b, that's fine with me. But I'm going to stick with the capital letters, just so this resembles what you'll see if you look this up somewhere, if you go to Khan Academy or something like that. Okay, so I know this is what my answer is going to be, and now I'm going to sort of work backwards from the answer. If I were to add these up, again, I don't know what a and b are, but I could still say, using the idea of common denominator, I'm going to have to multiply a by x minus 4, and I'm going to have to multiply b by x plus 1, doing the same in the denominators. And then I would add these up. So I'm going to have a times x minus 4 plus b times x plus 1 all over And at this point, we're going to pause and say, now I know this does have to actually equal 3x minus 37. I know that the numerator has to equal 3x minus 37. The denominators are already equivalent, so I don't really care about those anymore. So let's go ahead and now distribute. And so what I end up with, let's sort of ignore the denominator for a moment. I end up with ax minus 4a or a4 plus bx plus b times 1. And I know this has to equal 3x minus 37. So what this does for me is this tells me that ax plus bx has to equal 3x. Oops, equals, not plus. And negative 4a, let me continue color coding. Negative 4a plus b has to equal negative 37. And so really, I don't need these x's in here because they all have, each of these terms has an x. So I'm going to rewrite this one more time. And so I'm going to say a plus b has to equal 3, and then negative 4a plus b has to equal negative 37. And now you see we actually do have a system. We have two different equations with two unknowns we need to solve for, and we can solve it. So I feel like the best thing to start with is just to multiply the second equation by negative 1. So I end up with a plus b equals 3. And then I have, oops, skipping a step, I went to 5a. So 4a minus b equals positive 37. Adding these together, I end up with 5a equals 40, excuse me, and then a equals 8. Okay, so I know a equals 8. Let's go ahead and plug back into one of these equations. I'll just use the first one, 8 plus b equals 3, which means b equals negative 5. And we're actually done with the problem now, but please make sure you remember what you were doing and write this in the correct format. Too many people like to stop here and just say, oh, we're done, a equals 8, b equals negative 5. But keep in mind, we actually wanted a over x plus 1 and b over x minus 4. So it's going to be 8 over x plus 1 plus negative 5 over x minus 4, which you can just write as 8 over x plus 1 minus 5 over x minus 4. Or you could leave it as is. It's up to you. Okay. Now another question I get, so this is the answer, we're done. This is the final answer. But another question I get asked is, well, what if I did this differently? What if I said a over x minus 4 plus b over x plus 1. Well, if you did it this way, you would just get to the end, and you would end up with a equaling negative 5 and b equaling 8, which is the opposite of what we had. We had a equals 8 and b equals negative 5. But remember, these are just letters we randomly picked. It really doesn't matter which letters you used. And so when you put negative 5 in up here and 8 into this, you'll notice that you actually get the exact same answer we got. 8 over x plus 1, and then it's negative 5 over x minus 4. 8 is over x plus 1, and negative 5 is over x minus 4. So it will work out whichever letters you pick. All right, I'm going to do one more example. And in this one, it's not going to be nicely factored for you. So I'm just going to say find the PFD for, let's go 9 minus 9x all over 2x squared plus 7x minus 4. All right, so again, once again, we know that the final answer is going to be a over something and b over something, but we don't know what those somethings are because we need to actually factor the denominator first. So that's going to be our first step, is to figure out what our linear factors are. So 2 times negative 4 would give me negative 8. 2x squared plus 8x minus 1x minus 4. And so then going from there, we should end up with 2x minus 1 and then x plus 4. Just double check that this works. Yep. And so then I now have factored it, and I now have my linear factors. And so I know that my final answer will have the format a over 2x minus 1 plus b over x plus 4. In any problem you do, this is always going to be your first step. Please write this down whenever you're working on a problem, say on a quest, because this tells me that you sort of know what's going on at the very least, and then the rest might fall apart, but at least you know kind of the concept that we're trying to cover. So I know that the answer will look like this. Let's go ahead now and add these up. A times x plus 4 plus b times 2x minus 1. And then all of this has to equal 9 minus 9x over 2x minus 1 times x plus 4. And so what I like to do at this point is just kind of ignore the denominators and say a times x plus 4 plus b times 2x minus 1 equals 9 minus 9x. Now there is an alternate method to solve this instead of using systems of equations. I think what I'll do right now is just finish this up using systems of equations, and then I'll post one more video showing you the alternate method to do this. So here's where we're going to start. Let's go ahead and distribute. So I get ax plus 4a plus 2bx minus b equals 9 minus 9x. Let's combine all of the x terms. So I end up with a plus 2b has to equal negative 9. Let's go ahead and combine all of the non-x terms. 4a minus b equals positive 9. This is our system of equations to solve. I'm thinking maybe multiply this one by 2 and use elimination again. So we'll have a plus 2b equals negative 9. We'll have 8a minus 2b equals 18. Okay. And so I end up with 9 times a equals 9, which tells me that a equals 1. Let's go ahead and plug this back into the first equation. No, let's do the second equation. So it'll be 4 times 1 minus b equals 9. Excuse me. Subtract 4 from both sides, negative b equals 5, so b equals negative 5. And so then my final answer is going to be 1 over, let's see, what was that? 2x minus 1. And minus 5 over x plus 4. And that's it. So that is partial fraction decomposition. It's taking a rational expression and then breaking it down into two separate parts. It makes it easier in calculus to do something called integration if you can break large, messy terms into single terms that you can deal with.